We're standing right on the edge of a massive breakthrough in how we predict the weather, and it has everything to do with keeping our lights on when a huge storm hits. So today, we're going to dive into how AI is basically preparing our power grid for the fight of its life. I mean, it's a question we've all asked, haven't we? Despite all of our amazing technology, one nasty storm rolls through, and bam, we're back to the dark ages with candles. But what if the real problem isn't just the storm itself, but how we see it coming? All right, so to really get to the solution here, we kind of have to shift our whole way of thinking. For so long, we've been focused on this idea of building a grid that never fails. But what if that's the wrong goal? In a world with increasingly powerful storms, the real challenge is building a grid that can take a punch and get right back up again. Okay, so let's break this down. On one side, you've got reliability. That's all about just performing consistently well, day in, day out. But on the other side, you have resilience, and that is the ability to recover quickly from a major hit. They might sound similar, but believe me, that difference is absolutely everything. And that's because, let's face it, with the kind of extreme weather we're seeing more and more often, just being reliable isn't enough. I mean, think about it. A grid that can't bounce back from a hurricane or a massive wildfire. Well, that's not really a reliable grid at all, is it? Its real strength is now measured by how fast it can recover. And look, this isn't just some abstract idea. This is real. During Hurricane Idalia, Duke Energy's smart, self-healing grid in Florida prevented over 17,000 power outages. That's resilience in action, and it proves that having the right technology can make a massive, massive difference. So that success story out of Florida is incredible, but it's really only half the battle. You see, the self-healing grid is great at reacting to a problem, but what if we could see the problem coming with pinpoint accuracy? Well, that's where we've been hitting a brick wall, because our weather forecasts, as good as they are, have this tiny little blind spot that can cause huge problems. Yeah, this quote really nails it. A big, continent-spanning weather model just gives you averages. It doesn't care about the unique conditions happening on one single ridge where a crucial power line is sitting. But the person operating that grid, oh, you better believe they care. So what these grid operators really need are three things the old models just can't give them. First, hyperlocal forecasts that can see tiny, kilometer-scale terrain effects. Second, specific predictions for weird threats, like ice building up on a line. And third, they need actionable data, clear info that tells them exactly what to do and when to do it. And okay, this is where the whole game completely changes. A new type of artificial intelligence is emerging, and it's designed from the ground up to see the weather with exactly the kind of focus our power grid needs. They're called weather foundation models, and this is a fundamental shift in meteorology. The magic really happens in two steps. First, a huge AI model gets pre-trained on an unimaginable amount of global data. It basically teaches itself the fundamental physics of our planet's weather. Instead of scientists hand-coding every single physical law, the AI just learns the patterns itself. Then it gets fine-tuned on a specific, small set of data from a local region, and that turns this all-knowing generalist into a razor-sharp local expert. Here's a great way to think about it. The pre-trained model is like a world-class doctor who graduated top of her class from the best medical school on Earth. But the fine-tuning, well, that's like sending that doctor to a remote village to complete a specialized fellowship on a rare local illness. They become the world's #1 expert on that specific problem. And this is where it all comes together. The AI is kind of like a master chef. It takes all the global weather data, the public ingredients, and then it adds the secret sauce, the private, local data coming directly from the grid itself. The result is a custom-made forecast, perfectly tailored to the needs of that one specific power grid. So this all sounds great in theory, but does it actually work in the real world? Well, let's look at a case study from one of the most challenging environments you can possibly imagine, Quebec, Canada, where a utility called Hydro-Quebec put this technology to the ultimate test. Their specific villain is this phenomenon called rime ice. Now, this is not just regular ice. It's formed by these super cold water droplets that freeze instantly the second they touch a surface. It adds incredible weight to power lines, it's notoriously difficult to predict, and it is an absolute grid killer. All right, now check this out, because this is where it gets really impressive. When the AI model went head-to-head with the best traditional forecasts, it wasn't even a fair fight. A 15% reduction in errors for temperature and wind, that might not sound like a lot, but in the world of weather forecasting, that's a huge leap. And at 35% reduction in precipitation errors, wow, that is a total game changer. But that wasn't even the main event. For that specific grid-killing threat of Rime ice, the AI model achieved an incredible 8-fold improvement in detection. 8 times better. It was seeing something that, for all practical purposes, was previously invisible.
Now, these charts might look a little complicated, but they tell a very simple story. The AI won. Period. On the left, that blue line soaring way above the others, that's our AI model. The higher the line, the better the forecast. And as you can see, it's not even close. And on the right, you see that victory in action. The dark blue areas show the AI predicting a major icing event with high confidence, days before it even happened. This is what it looks like to see the future.
So, we've built an AI brain that can see the future. That's amazing. But a brain is useless without a body to act on its commands. So how do we give our power grid the reflexes to match its brand new intelligence?
Right, because a perfect forecast of a disaster is totally useless if you can't react. And that's the other half of this revolution, the self-healing grid. It's the automated system that can take the AI's warning and just spring into action. And it works in 3 simple steps. First, sensors detect a problem, say a power line breaking under the weight of that ice the AI predicted. Second, automated switches instantly isolate that broken section. And third, power is rerouted around the problem, almost like a GPS detour, restoring electricity to most people in milliseconds.
Duke Energy describes it perfectly. It's a GPS for electricity. It sees a traffic jam or an accident up ahead, and it instantly calculates a new route to keep things flowing, all without a human ever touching a thing. So when you put these 2 pieces together, the AI that can see disaster coming and the automated grid that can react instantly, you get more than just a stronger grid. You get a much, much smarter one. And this is more than just an upgrade. It's a fundamental shift in how we think about our infrastructure. For decades, we've been in a constant state of reaction, right? Waiting for things to break and then scrambling to fix them. But now, for the first time, we have the tools to be proactive, to be preemptive, to see the storm coming and get ready for it before it even hit. You know, this leap forward doesn't just stop at our power lines. It really makes you wonder, if this combination of a hyper-aware AI and an automated response system can safeguard our energy, what other critical parts of our world, our water systems, our supply chains, our transportation networks, what could it protect next?